This is the Safe by Kevin Grant and Alex Kim. I'm Kevin Grant speaking. I worked on the assembly of the actual project, and then as far as code, the buttons and the photoresistor were my main focuses, while Alex worked mainly on the report, our accelerometer code, and our microphone. More on all of those details later. So just a quick little demonstration. So this is the Safe. As you can see, we have our buttons on top that are used to open it, and you have to press these in a certain order. Of course, nothing's primed right now, but you'd have to press your buttons in a certain order, and you can set the order however you want to open the safe without the alarm going off. Now the inside is a bit of a mess, of course. There are a few loose wires at the moment because I didn't have the buttons plugged in just for ease of seeing everything right now. But if I get in here, you can see that we use our accelerometer, the photoresistor right here, and the microphone along with the speaker. The accelerometer is there so that anyone can, while the safe is locked, no one can shake the safe violently or anything. The photoresistor is there so that if anyone manages to open the safe without having input the code, our little alarm will sound on the buzzer. And the microphone is there, for once again someone banging on the safe trying to open it using a saw, a drill, something like that. It's going to be loud. So we're looking for loud, large discrepancies in noise, so that we can start sounding the alarm. So this is the accelerometer. So as I mentioned, it looks for discrepancies in how the safe is being moved. The actual way it's doing that is by using a moving average filter to look for discrepancies in the way it's been being moved. If those discrepancies exceed our threshold, the alarm will start sounding. There'll be an example of the alarm going off later, farther down, and this of course disarms when the safe is unlocked. The microphone, very similar to the accelerometer, it also uses moving average to look for discrepancies in noise. If someone tries to break open the safe with, as I mentioned in that video, a drill or a saw, the noise is going to trigger the alarm, and then once again disarm the safe is unlocked. Photoresistor is a much more simple piece. It's just simply looking for the presence of light. When that light starts shining in and that resistance changes on the photoresistor, it's just going to start sounding the alarm if it hasn't been unlocked yet. And that's just a very simple way of finding out whether someone's looking at it, whether that means it's a thief with a flashlight trying to break in and open your safe, or just it opened up and there's a light on in the room. It's going to sound the alarm. Here's a little example of that photoresistor in action. Now those buttons, it's pre-programmed order. The buttons must be pressed to unlock the safe. If they're pressed in the wrong order, I didn't have it set up so that the alarm goes off. I figured that you get a few wrong tries. Everyone messes up the code every once in a while. But if you hit the wrong button in the wrong order, it just resets back to the beginning of our function that is looking for when the button presses.